Hey everybody, so today we're going to be learning from Lesson 6. So we're almost done with Chapter 6. Lesson 6 is one of our last lessons. We are learning the distributive property. In Lesson 5 we learned about 3 different properties. Today we're going to be learning only the distributive property. And then we also took inquiry lab notes in class to kind of help us from that shift from lesson 5 to lesson 6, okay? And so we explored some of the distributive property. Today we're going to be learning exactly what it is and how to solve problems using it. This is our inquiry lab notes in case you didn't get it or missed something. Go ahead and pause your screen and just finish those notes. Okay, so the distributive property, I already have it written on my paper in the main ideas section. I'm going to start writing in the notes section. So in our inquiry lab, a lot of what we were doing was exploring how we go from one rectangle in an area model to using 2 rectangles, okay? And that's kind of what the distributive property is. So let's real quick just draw so we can visually see what it is. Okay, so if I have a rectangle and this side length is A and this side length is B, and then I have C for that side length, okay, I can also say I can draw another area model showing 2 rectangles. And again, this side length is A, this side length is B, similar to this rectangle here, plus this side length here and this side length here, so A and C. Okay, so I just separated this one rectangle into 2 rectangles. So I have side lengths are the same for A, and then I have B and C as side lengths on the top. So we talked about how one rectangle is the same as the sum of 2 rectangles, okay? And then one thing to note, this model that we drew here, it's very similar to the situation that we had in the inquiry lab notes. Okay, so if you look at the inquiry lab, we had a number here, 3. So we could imagine this A being 3, our 3 friends. Okay, and then we had $6 and $22. So B could represent the $6 you'd pay to get into the fair, the admission, and C could represent the $22 that you paid to get into the concert. Okay? So again, we are doing the same thing that we did in the inquiry lab, but this time we use variables for everything. And that's what we're going to be seeing a little bit today. So I'm just going to write an expression for this. A times B plus C in parentheses, because up top here to get this side length, we have B plus C. Okay, so we always have length times width equals, now I'm going to draw an expression to showcase this area model, A times B to get the area for this rectangle, plus A times C to get the area of this rectangle. Okay, and what we explored in the inquiry lab is that these 2 expressions are equivalent. Okay, so they're the same thing. Notice as well that A times B plus C, it's the same over here because if we multiply A times B, we get that right here. And if we multiply A times C, we have that right here. Okay? So the distributive property distributes this outside variable or number to the inside of the parentheses. Okay, distribute, you could say like it, I forgot the word, distribute, it gives it, okay, just like when I'm passing out papers, I'm distributing papers, okay, so I'm giving this A to the B, so it's being multiplied, and I'm giving this A to the C, so that's being multiplied. Okay, I'm distributing the A to everything inside the parentheses. So A times B, we have that here, and A times C, we have that here. Okay, so that's the distributive property. Now, let's work on some problems. I have about 3 to 4 examples for you. They're all different. So we are going to rewrite 4 times x plus 3 using the distributive property. And dp, I'm just going to write short for distributive property. Okay, so rewrite the expression here. We have 4 times x plus 3. Now, in the inquiry lab, we talked a lot about using algebra tiles and how we consider the algebra tiles. It might help us to think of fries and chicken nuggets. So when we see the smaller rectangular, and it's kind of long, the smaller rectangular algebra tile, that is our x. That's our variable, okay? It's also what we consider as a French fry. The little cubes, those are the chicken nuggets, okay? And they stand in place for an integer, a number. So I'm going to model x plus 3 with algebra tiles, fries and chicken nuggets. Okay, so x, here's a French fry, plus 3 chicken nuggets. Okay, but this 4 on the outside tells me that I have 4 sets of x plus 3, or that I have 4 groups of x plus 3. So I need to make 4 groups of this. Okay, so I have 4 groups of x plus 3. Now, I'm going to rewrite it on this side, but I'm going to combine them. So we talked about how we can't combine variables and numbers, okay? You just can't. You can't add them together. Like you can't combine them. It's just x plus 3. Just like we cannot combine French fries and chicken nuggets. Okay, but we can group them together. So I can group all the French fries and I can group all the chicken nuggets. So I have 1, 2, 3, 4 French fries. So I'm drawing 4 French fries over here, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 chicken nuggets. Okay, so up here I'm going to write 4 French fries, so 4x plus 12 chicken nuggets. So again, we have the same format over here, okay, as we do up here, right? So here we see the distributive property, okay? We have 4 times x plus 3, similar to how we have it written up here. And then over here, if we use the distributive property, so we do 4, we distribute this 4 to the x, we'll end up with 4 times x. And we distribute this 4 to the 3, then we're going to end up with 4 times 3. Just like when we distributed this a to the c, we had a times c, like right here, a times c. Well, now we have 4 distributed to the 3, 4 times 3 is 12. Okay? All right, next example. Find 9 times 8 and 2/3 using the distributive property. Okay, so find 9 times 8 and 2/3 using the distributive property. All right, so instead of making a model this time, sometimes in the book they're going to tell you to do this mentally. So we are still going to use the distributive property, but you may not need to draw out the chicken nuggets and french fries. You can if that helps. I know it helps me and it helps a lot of other students. So you can always draw a model, but now for this example I'm not going to draw a model. So I have 9 times 8 and 2/3. Okay, well, let's say that again. 9 times 8 and 2/3. One key word is the word and. So and a lot of times tells us that we're adding. So instead of this being one number, it could be written as 8 plus 2/3, which would look a lot like this, right? 9 times 8 plus 2/3. Okay, so we are going to use the distributive property to solve this. So first thing I'm going to do is distribute this 9 to the 8. So I have 9 times 8 equals 72. And then I'm going to distribute the 9 to the 2/3. So then I'm going to multiply 9 times 2/3. Okay, and we remember how to do this from a few lessons back, a few chapters back actually, multiplying a whole number with a fraction. Okay, so we can imagine that there is a 1 in the denominator. Okay, every whole number has a 1 as its denominator. Then we can just multiply across, so 9 times 2 is 18, and 1 times 3 is 3, and then we can simplify, okay, turn it into a whole number. So 3 goes into 18 6 times. Okay, now on the side over here, we're going to add these two together. 72 plus 6, 78 is my answer. Okay? So by using the distributive property, we distributed 9 to the 8 and the 2/3. We multiplied them, and then we added them on the side. All right, next example, and I'll just highlight a little bit real quick here. Okay, so next example, we are going to use the distributive property to multiply 8 times 57. So it's a similar example to this, but now we have a whole number. And instead of just multiplying 8 times 57, what we're going to do is break up the 57 so that our form, the way we write it, can look really similar to this. Okay? So I have 8 times, I'm going to break up the 57 into 50 and 7. So 8 times 50 plus 7. Because if I add 50 plus 7, I'll get 57. So I'm not changing any of the numbers. Okay, I'm not changing this sum, so it's something different. I'm just breaking it apart so that we can use the distributive property. Okay, and I broke it into 50 and 7, so that way we have a nice number with a 0 to work with, and we can do some easy mental math, okay? So first I'm going to distribute the 8 to the 50. Okay, and then I'm going to distribute the 8 to the 7. And the word that I just remembered that I was trying to remember earlier when I was describing distributing this number variable on the outside is pass out. So we are going to pass out this 8 to the 50, and this we're going to pass out this 8 to the 7. Okay, just like when we're handing out papers, we're distributing it. We're multiplying. By distributing it, we're multiplying them. Okay, so 8 times 50 and 8 times 7. All right. 8 times 50, if I do that mental math in my head, that's 400. And 8 times 7 is going to be 56. So then I can just add those on the side to get my answer. 400 plus 56, you get 456. All right, so again, I just distributed the 8 to both numbers, multiplied them, and added them to get my answer. Okay, last example. This is something different than we've done before. You'll remember some of the steps and how to do it, but it's going to be a little different, and it's something that you should pay close attention to. So we are now going to factor the expression 54 plus 24. So we're going to factor the expression 54 plus 24 so that it looks like this. And I'm just going to use blanks because I don't know what the numbers are yet. Blank plus, okay, so blank times whatever is in parentheses, blank plus blank. This looks very familiar to what we have up here, right? It's in the same form, okay? So we want to get this into this. If you notice, this right here looks a lot like what we have over here. 4x plus 12, kind of similar, right? So we want to change that so that it looks like this, okay? So we're kind of going backwards. So in order to go backwards, we need to factor this expression. And factor means that you're multiplying, right? Because a factor of something, you know, factor times a factor equals a product. I say that a lot in class. So factor, think of it as multiplying. So we have to get this, so that's multiplying, okay, and we're going to use a distributive property. So first thing we're going to do is make factor trees for 54 and 24, okay? And you might remember factor trees from our previous chapters, okay? So I can think of any two factors of 54. So, like, I could think of 1 times 54, but that wouldn't help us too much. I could think of 2 times 28. No, 27. 2 times 27. Sorry, my mental math is off. But two numbers that really pop into my head are 6 and 9. 6 times 9 would give me 54. Okay, now I'm going to factor it. I'm going to use prime factorization. I'm going to get it all the way down to its prime numbers. Okay, so 6, two factors that multiply to 6 are 2 and 3. But I've got them into their prime numbers, prime factorization. So I can circle them, saying that I'm done. It's a dead end here. I can't factor anymore. What multiplies to 9? 3 and 3. 3 is a prime number, so I'm going to circle it, saying that I cannot go any further. I'm going to rewrite it in the order that I have it here. So 2 times 3 times 3 times 3. So this is the prime factorization of 54. Okay, we're going to do the same for 24. So two numbers that just pop into my head are 4 and 6. But you could use a lot of different numbers here, okay? You could use 8 and 3, for example. So now I'm going to do the same thing. 2 times 2 is 4, and 2 is a prime number, so I'm going to circle it. Okay, 2 times 3 would give me 6. 2 and 3 are both prime numbers. I'm going to circle it. Okay, so now that I've gotten the prime factorization of 24, I'm going to rewrite it. 2 times 2 times 2 times 3. Okay, and now I'm ready for the next step. The next step is to identify a couple of the factors that they have in common, or all of the factors that they have in common. So I noticed that the only two numbers they have in common are 2 and 3, and those are the only numbers that there really is here. There's no other numbers besides 2 and 3. Okay, so I noticed that their first two numbers they have in common are 2. So I'm just going to put a box around that. And the other two numbers I noticed that they have in common in order, okay, this 3 matches with this 3. Okay, so I found the numbers that they have in common. I'm going to rewrite this over here. Because again, this is what I want. This is the format that I want this to be in. Okay, I'm rewriting this expression as this. And this process is going to help me write it like that, okay? So the numbers 2 and 3, I've matched them, and now on this side, if I multiply 2 times 3, I'm going to get the number that should go here. Okay, so 2 times 3 is 6. Now, to find what should go in the other spots, I'm going to look at what is left on this side and what's left on this side. So on this side, we have 3 times 3 left. Okay, so I'm going to put that 3 times 3. It's going to go right over here. And 3 times 3 is 9. Next, I'm going to look at what I have left here. And what I have left is 2 times 2. So I'm going to put that 2 times 2 over here. 2 times 2 is 4. Alright, so I'm just going to quickly color code. Okay, so hopefully with my color coding it helps you kind of see what I used over here to get these numbers. Okay, now the last step, since we have our correct format, we've factored this expression into this format. This is our answer. You don't have to do anything else. This is the answer. But I do want to check our work, okay? So it's always good to do a little check. So over here, we're just going to check our work. And we are going to do the opposite now. we are going to use the distributive property to see if we can come up with the same answer. If we come up with the same answer using the distributive property, okay, then we've done an awesome job and we got the correct answer. So I'm going to use the distributive property. 6 distributed to the 9. It's going to be 6 times 9. And then I'm going to distribute this 6 to the 4. So 6 times 4. 6 times 9 is 54. And 6 times 4 is 24. Okay, so if you see here, I got the same answer, 54 plus 24, 54 plus 24. So that means we did this correctly. You might have to rewatch this part of it because there's a lot of different things that we did here. We started off with factor trees, and then we had to look at the factors they had in common. The first factors that they have in common, before we run out of numbers, goes in this spot here. So we did 2 and the 3. They have the 2 and the 3's in common. We multiplied those, 2 times 3. Then whatever numbers they had that was left, whatever factors, we multiplied over here, and the 2 times 2 we multiplied here. And then just do a quick check to make sure you did everything correctly. You will have a lot of practice to do this, and if you have any questions, just let me know in class.